Hello everyone, in this video we are going to see how we can run Bellman Ford algorithm, and how Bellman Ford algorithm works, and later we can discuss what are the merits and what are the demerits of the Bellman Ford algorithm. So basically first we will do a quick recap what Bellman Ford algorithm do. It solves the problem of a single source shortest path. So what is the problem? What is single source shortest path problem is, suppose from node 1 we need to go to node 2, node 3, node 4 and node 5 and node 6 and node 7, but our constraint is we want to go to the cover to minimum distance. For example, if we want to go to reach to node 7, but we want our path should be the minimum one. So if we want to go 1 to 3, 3 to 5, 5 to 7, we have an option. If we want to go 1 to 4, 4 to 6, 6 to 7, we have an option. But we want to select a best path. So basically we want a minimum cost path. So this is what is known as single source shortest path problem. From a single source, we want to find a minimum distance from to all the other nodes. Now the first thing is, Bellman Ford algorithm uses dynamic programming strategy, and where Dijkstra uses greedy strategy. In Bellman Ford algorithm, we can find a minimum distance even our edges are negative, but we can't do this thing in Dijkstra algorithm because it doesn't support negative weight edges, but Bellman Ford supports weight edges. So what is dynamic programming strategy? So dynamic strategy says to try out all the possible solutions and then pick out the best one. So basically what we are going to do, we are going to take account all the possible solution, and in the end we are going to pick one solution which is the minimum cost solution. So let's see a quick live example how Bellman Ford algorithm works. So in this graph, as you can see, we have node S, A, C, B, and we have edges S to A to C, S to C, C to B, A to B. So the first step is to list down all the edges in any order. Like I have listed in this order, you may change this order. So you just have to list down all your edges, C to B, A to B, C to A, S to A, S to C. Then, so first, Bellman Ford algorithm says to count the number of edges. So as you can see, the number of edges in this graph, we have 1, 2, 3, 4, 5 edges. Then we have to calculate the number of iteration value, which will be equal to number of edges minus 1. So in this example, as we have 5 edges, so our number of iterations will be 5 minus 1, that is 4. So that's why we have iteration 0, iteration 1, iteration 2 and iteration 3 here. So now let's see how it basically works. So now we are at iteration 0. So first step is to give 0 to the source and mark infinity to the rest of the nodes. Now we will process the edges in this order. How many times? N minus 1 time. Number of edges minus 1 times. So we are doing our first iteration. So our first edge is C to B. So C to B. So the cost of reaching B from C will be infinity plus 1. We need to check if it's less than infinity. No, it's same. So we will not change it. We have covered C to B. Now we will take A to B. If we go A to B, it's infinity plus 2 less than infinity. It's the same. We can't change. It's done. Now we will see C to E. So infinity minus 2 is less than infinity. No, it's the same. It's done. Now from S to A, we have 0 plus 1 is less than infinity. Yes, it's less than infinity, so we will update this. Now again, this is done. Now we will take s to c. S to c is 0 plus 2. 0 plus 2 is less than infinity. Yes, it's less than infinity, so we will update this. So we are done with our iteration 0 and iteration 1. Now again, for the second iteration, we will do the same step, which is c to b. Now the cost is to go c to b is 2 plus 1 is less than infinity. Yes, it's less than infinity, so we will change this to 2. This is done. Now a to b. A to b is 1 plus 2 and the updated is 2. Is it less than? No, we will not update the distance. Close. Now see c to a. C to a is 2 minus 2. 2 minus 2 is less than 1. Yes, so we will update this to 0. This is done. Now s to a. S to a is 0 plus 1 is less than 0. 0 plus 1 is less than 0. 1 is less than 0. No, so we will not update this. Now from s to s, we have 0 plus 2 is less than 2. It's the same. We will not do anything. So we are done with our iteration 2. Last iteration is c to b. C to b is 2 plus 1, 2. No, we will not change the anything. Now a to b is 0 plus 2, 2 is the same thing. We will not change anything. Now c to a is 2 minus 2 less than 0. We will not change anything. From s to a, 0 plus 1, already 0. We will not change anything. From s to s, 0 plus 2, and we have 2 here, so we will not change anything. So we are done. So what you can see now is the final distance, a minimum cost required to go from s to a is cost 0, from s to c is cost 2, from s to b is cost 2, as you can see here. So from s, so to a we can reach to a in a 0 cost. We can reach from s to b, we can reach in a 2 cost, and from s to c we can reach in a 2 cost. So this is how Bellman Ford algorithm work. So let's discuss now a Bellman Ford algorithm, what we are doing. So Bellman Ford algorithm says to give for all v in v. So for all the vertices or nodes, whatever we want to call, all vertices or nodes, give them value infinity, as we did in our example. After for loop, what we are going to do, we are going to assign to our source or parent a value 0. As we did, we provided source 0 and all the other vertices we provide infinity. So now for each u to v in E, we are going to update the distance. If it's minimum, then we are going to update our distance. So this is how Bellman Ford algorithms work. So for now, as you may see, we have for the first for loop, it will take ov of time, and then we have a nested loop. It may require ov of time. So in total, if we require this much time, so it will be, we can say n square, ve plus n square. So this require big O of n square in the worst cases. So the main disadvantage of the Bellman Ford algorithm is it did not support negative weight cycles. So if a graph is forming a cycle with a negative weights, Bellman Ford algorithm will fail. So n-1 time is our number of iterations where we have to stop, and if we don't stop, it will go beyond that. But Bellman Ford says you have to go to only n-1 times. If it didn't have negative weight edge cycle, it's for sure going to work for your graph. But if it have negative weight edge cycle, it will not work. So Bellman Ford algorithm says I can help you to detect the negative weight age cycle. So the thing is, if we run one more time to this iterations and we can see if the weights are changing, if we updated anything, then we can say it contains negative weight age cycle. And if it says no, I haven't changed anything, so then it's a pure Bellman Ford algorithm that works. So if it says yes, I run one more time and there are some changes in the weights, so it means that your graph contains negative weight cycle. we can One can deduct negative cycles by checking whether distance estimates can reduce after 1 minus 1 iteration. So for example, if you have a cycle like this, so it's going to be fail. So the only thing we can do with Bellman Ford, if we can detect whether we have a negative weight cycle, Bellman Ford fails. So if you're sure your graph don't have negative weight age cycle, then for sure go for Bellman Ford. And because Dijk's algorithm don't support negative weights, Bellman Ford algorithm supports negative weight, but it doesn't support your negative weight cycles, so you can't use in this case. But there is a best way you can detect it if there is negative weight age cycle. Thank you for watching. If you have any suggestion, any comments, please write down below on the comment sections, and please tell how did you like the video. Keep watching.